Hi folks, today we're going to check a high power transmitting tube for gas. The problem that we find over time is that glass to metal seals may not be made properly. So what happens is at a microscopic level, gas will come up through the glass to metal seals here and fill the tube up with gas. And when that happens, bad things take place when you put power on this tube. Don't ask me how I know this. Let's just say that if you've got a tube and it's full of gas and you put power on it, a couple, 2, 3, 4,000 volts at real current, typically you'll blow fuses at the very least and probably destroy your power supply. This here is a basket case. It's a perfect test subject for this. This is an Eimac tube. This is a 3500Z. Sorry, we're in the dark here. Right here, you'll see a date code. It's 9041, so it's 1990, 41st week. I believe that Eimac moved out of California and went to Utah in 1989, and apparently they lost some tribal knowledge because a lot of the tubes of this particular vintage here will get gassy. There is possibly a way to degas them by gettering them, and that'll be the subject of a future video. Some tubes you can heat up and actually at a lower voltage and actually recombine the gases and use the tubes, and others are just so far gone that you can't do that. Okay, so we have our test subject here. This is a little test board that I've built. These two pins here are the filaments normally, and these other three are the grids. And this is the plate lead here. So what we're going to do today is we're actually going to go from the grid to the plate, and that's close enough. Any one of these elements to each other will show you leakage. You don't need a whole heck of a lot of voltage here. You cannot measure this on a standard voltmeter, a standard multimeter. So if you put a Simpson 260 on this, you're not going to measure anything at all. It's going to look perfectly fine. Typically what I do is I use my variac here, and then I use a high voltage transformer of some sort. this this fence charger, quote unquote, designed for pets. I love it. Probably made by the same people that designed the Velodog revolver to be used by French bicyclists. So if a dog comes up to a bicyclist, you pull the Velodog revolver out and shoot the dog. That's crazy stuff from a century and a half ago, and I think the same people or descendants designed this for pets. Anyways, I checked this out, and this is about a 2,000 volt AC transformer, low voltage, low current, and this is more than enough to do the job. The other thing I usually use is a neon sign transformer, and those will go to like 11,000 volts. They're overkill, but again, if you use a variac here, you're good. Okay, let's go ahead and fire this thing up, and you'll see here pretty soon why we have it dark here in the room. I'm going to plug this in. You can see this is off, and also what I've done is I've turned the voltage down on this. You never leave the voltage up when you plug something in. Bad things can happen. So we've turned the voltage down, and now we're going to plug in the power cord to the Design for Pets Zappin setup here. I'm going to kick the light off, and here we go, folks. Here's the fun part. And we're going to slowly run the voltage up. Oh, crap. I think we have a problem here, Houston. Oh, yeah, look at that. Wow. Let's see where we're at. Right now, that's about 80 volts. So we're 2/3 of full voltage. So that's probably about a kilovolt and a quarter or so. Yikes! Look at that. If that would have been plugged in and turned on, it would have been lights out for that particular amplifier. Let's run this up all the way to 2,000 volts, and just gets a little bit stronger there, and you hear that beautiful AC hum coming out of the power supply. And we're not pulling a whole heck of a lot of current, but we'll run this thing back down here. So basically right about there, full tilt. Yep. This one's done. Hope this was helpful, folks. Thanks for watching.